So this is the build video for the PunkSeq10. It's a very simple sequencer. So this is one of the prototypes. So this is the kind of thing. This is what it's going to look like basically when it's built. But let's go ahead and build one. So when you receive the kit, you should get a pack something like this. Open it up and be careful not to drop anything because there are some loose kind of parts in here. So if you open it up, there'll be another little bag inside, which contains a bunch of the components, so all of the ICs and LEDs and things like that. There are also two strips of components with the diodes and the resistors, and you get all of the knobs. These are the knobs for the resistors, just kind of hanging around. The build is it's not a quick build. I guess I'm expecting this video to take about 30 minutes. Basically, that's kind of how long it took me to build it when I was doing it myself, and under the camera it might take a little bit longer. The build order is also kind of a little bit important in that you have to make sure you kind of do the LEDs first, because the LEDs, the way the board is constructed, the LEDs mount under the variable resistors. The reason for that was basically to try and keep the board size down. It's the only real way that I could get it into a 10 by 10 size, but it is kind of cool because the LEDs shine down, so if you have it on the surface you can see them shining against a surface. So okay, so you should see all of the components kind of laid out like this, and we're going to start with the LEDs. Now you should see on the LEDs there's a flat edge. It's important to identify the flat edge, which is the shorter leg, and that's going to match up with the marking on the board. On the back of the board there's a flat edge, so you'll want to put it with the short leg facing inwards, so it's always facing inwards, so they're facing inwards on that side and that side, so it changes in the middle, so just be kind of careful. It's kind of up to you how you do this. If you're like, this video is not for someone who knows how to solder. If you know how to solder, everything's marked out on the boards. The resistors are all the same value. There's nothing you really need to be very careful about in terms of placement. So if you know what you're doing, you've soldered before, you can just go ahead and build this board up. This video is just a kind of reference in case you run into any issues. Okay. So when I do it, I quite often just poke all the LEDs through first. So let's see how that goes. It's quite difficult because there are an awful lot of LEDs. They have a tendency to fall out. But I'm just going to push them through, I think, and then solder them up. So it's good just to check you've got the flat edge. Sometimes a little bit difficult to see, so it's better to go by the legs. So the short leg is going inwards. So I'm going to push them through, and then I'm going to bend the legs of it just so they don't fall out, and then I'm going to tack them, make sure that they're fully pushed through, and then after that solder them in properly. So when you go halfway through, you should make sure that you're switching the build order, or the direction of the LEDs, so that they're always facing inwards. looks good. So once you've pushed them all through, just have a quick visual check. Make sure that flat end is always facing inwards. And then we can turn it over and start soldering. And like I say, I'm just going to solder in one leg and then I'm going to move on to the other one. And today I'm going to try, this is the first time on video, trying to use unleaded solder. Generally I use leaded solder, but I've been using unleaded a bit more lately because it's better for production, and also I get slightly paranoid with kids around with leaded solder, so we're going to go with unleaded. I'm just going to solder in one leg of each first. I'm just going to actually knock the temperature up a little bit. I like to use a slightly higher temperature. I use 350 C for leaded solder. For unleaded I like to use like 360 or something. Just because unleaded solder does not flow as nicely. So it's up to you how you do this really. Obviously you can also do just like half at a time or something if you don't like the legs getting in the way. So hopefully you can see what I'm doing. One thing that's nice about putting all of the LEDs in at once is that they kind of help stabilize the board, so you kind of can do it with the LEDs, the board just resting on the LEDs, and it rests pretty flat, so that's good. Okay, so once I've soldered in one leg, I just want to check that none of the LEDs are kind of pushed out a bit or out of alignment, and those look all fine to me. So I'm going to go ahead, and I think to make life easier, what I will do is cut off, so I can find my wire cutters. So it's a nice new pair of wire cutters. So I'm just going to cut off that leg. I think on the documentation I have listed all of the tools I use. But I'm using Hosan N34 wire cutters, which are my favourite. But the important thing is just wire cutters with a nice flat edge. So the ones you pick up quite often in hardware stores have these kind of rounded edges, which I guess have been grinded down or something. But these have nice flat edges. That's about it really. So you get a nice flat cut. You want to try and cut these quite close to the board, because the variable resistor, the pot sits on top of them, and there's not a whole lot of clearance. So the closer they are, the easier it is when you go to put the pots in. Okay, so just going to do all the other legs. So I found now I've kind of got used to unleaded solder now, so I'm finding it a bit easier to do things, but it's not quite as shiny, and it kind of it solidifies very quickly, so it goes solid very quickly. So you have to be a bit careful. There's a tendency for the solder to stick to the pad if you don't. You have to make sure you pull it away properly. So I'm just holding onto all of these pins so they don't go flying. Hit you in the eye or something. Okay. So that's all their LEDs soldered in. I want to make sure that they're cut quite close to the board, so anything that's kind of sticking up a bit I'm clipping off. That looks good to me. You could do it all surface mount as well. That was one thing I was thinking about, and actually I have this is like going to be a surface mount version with fixed resistors, but it's nice to have a through hole kit. Okay, so next I'm going to do the pots, and the pots, as I said, sit over the LEDs. So you just want to push them over, stick them over the LEDs, make sure they're kind of pushed in. They will actually cut into the they'll cut into the board a little bit, so you have to apply a little bit of pressure to get them in. I think that's okay. So I'm just going to bend the legs as I push them through, just to keep them in. I also sell these like pre-assembled, so if you want it but you don't want to go through all of this hassle, I will assemble it for you. So getting the alignment of the variable resistors is kind of important, because otherwise it looks a bit odd. So for that reason I'm just going to do one pin on the variable resistors at first again, and then I'm going to stick all the knobs in, and we're going to check that it looks okay. I'm just doing all the top ones at the moment. I'm not doing the other two, so I'm just going to solder in this bottom pin. Again, it kind of sits nice and flat if you put them all in, so I like to do them all at once. Just have to flow in quite a bit of solder just to make sure. There's a bit more. Just to make sure you cover that hole. I think actually this time, with the fact that I'm using the pots to stabilize the board, will help keep them in alignment, so we may find that the alignment just looks good. Anyway, we can hope. So I think if you've never done soldering before, this is kind of not a great project. It's maybe a second or third project. It's designed so when we look at the other side of the board, you'll see that you've got basically the same Atari Punk console layout. I kept the exact same layout as the Atari Punk console kit that I also have in the shop for the Atari Punk console section. So the idea is, if you've built the Punk console already, there's something for you that you're kind of familiar with, and you can go, okay, I know this is like a progression of that. So, and the same from the circuit point of view, you can kind of look at the circuit and say, oh, well, that part is I did that before. That's the Atari Punk console part. And then there's the decade counter separately. Okay, that looks good to me actually. Yeah, so this is the Atari Punk console, and you can see the kind of the outline, which is the board outline of the Atari Punk console. So this is just really like an Atari Punk console plus sequencer. Okay, so I'm going to put all the knobs in just to check that it looks okay. There'll also be, with the kit, like a paper build guide, which you can kind of look at, and if you don't want to watch this no doubt horrendously long video, but the video is here as a reference for anyone who wants it. So that looks kind of okay. This one, you can just poke them so they sit in alignment. Just make sure everything's kind of nicely lined up. I'm happy with that. And then I'm going to solder up the rest of the pins. Let's do this one first. The other thing I've added since the first version, so the first revision didn't have the step selection switches, which I've added, and the other thing I added was a bunch of mounting holes. So you can see here and here and here and here, a few little mounting holes, which you can you can use for mounting it either in a kind of, I would guess, like a piece of acrylic would be nice and easy thing to mount it on, or someone kind of suggested that for events and stuff you could wear them. So the idea would be you could put like a piece of thread through them or something and wear them like a piece of jewellery. But I think also for that you will want some kind of enclosure maybe. But I figured I'd put them on just in case. What's that? Turn that off. It's really all of these. Like the fact that there's quite a lot of components to solder in batches of 10 for each of the steps that takes the kind of time. So if you don't have the time to do it all in one sitting, what I'd recommend doing is just getting making sure you can do one of the batches of 10, like so do all of the LEDs and then put it to one side, and then look at all of the pots, and then the next thing we're going to do is all of the diodes and resistors. So that sort of takes time really. It's just repetitive, doing the same kind of component again and again. It's going to get even worse because I have a design for a 32-step sequencer in the works. Someone requested that, so that I think will take quite a while to assemble. So it's not clear if that would be a great kit or not. Let's see how that goes though. That is designed with CV and gate outputs, and it's designed around an Arduino, so it's kind of a programmable thing. This can be hacked actually to have CV and gate type outputs. But it's really designed like a standalone kit. So you could also like hack it for like the output to a jack, so you could wire it into other equipment, and I have done that for the Atari Punk console for some people. But I'm planning to design another little board that will take what is the speaker output on this board and then output it to another little board that goes to, that lets you switch between a speaker and like a jack output. Okay, that's good enough. I'd like to go around and just clean those up, but I think the video is going to be long enough as it is, so I'm going to leave those. So I'm going to take out the knobs again for the rest of the assembly. They're just kind of in there to make sure the alignment is looking good. And let's go ahead and do the next bit. What should we do next? Let's do the diodes. So you kind of have to bend the pins on the diodes and then just put them through the holes. You can see on the diodes they're marked. One end has a black marking on it, and that aligns with a little the marked area on the board here. So this is where the black pin goes. Getting these bent to the right. So you just want to bend the legs. But getting it bent exactly right is always a bit of an art, and probably on the camera I'm going to screw it up a little bit. But there we go. That's the wrong way around. That's not good. But the bending was okay. So yeah, you just want to bend the legs and then push them through. So it gets trickier to get things properly aligned now, because you can't lay the board flat anymore, because there's components above where like the diodes lay. So one thing you might want to do is use a bit of tape to hold the components in. What I tend to do is do as I did with the LEDs and just like solder one leg down, make sure it's in alignment, and then do the next one. So I also saw a cool little tool to help you bend these legs the other day on Twitter, which I don't have, but I feel like I now want. It's basically just a piece of plastic with a bunch of measurements marked on it, and you can put the component in the slot and bend it. But for a bent piece of plastic, they're surprisingly expensive. You know, they're like a $5 or something. So I didn't buy it, but I'm thinking about making my own. That's not very nice, that one, but there we go. So it is kind of fiddly getting the right size, so I would like it with a tool, I think would be nice. Just for consistency. Okay, that's them all in. Now I'm just going to hold them in by hand, and then I'm going to bend the legs just to keep them in place. So you want them kind of not to fall out really, or not to move too much. Okay, let's do that. Let's solder. So I'm going to do the inside on first, because that's easier. So when I bent the legs over, I just kind of made sure by turning over the board that it was like the bending was enough to keep the components in alignment. So they didn't fall back through when I turn the board over. So just shake it around a bit and make sure that's okay. And and that will hopefully make sure that they don't move around as I'm doing the soldering. The moment of truth will be when I've done this. But by doing one leg only, you know, you have a bit of flexibility to realign things afterwards. If you've soldered them both in, it's a pain to get the component out again and line things up. Okay, that looks good. I just do a quick check again that they're all in the right way around. Should it appear to be. And then let's cut the legs off and go for the other one again. Okay. So I think I said half an hour. That was clearly wrong. It's going to be a lot longer than half an hour. I would say probably at least an hour. Okay. Next, resistors. So I've got the next strip of resistors, and these are all the resistors on the board are 1K. So there's no confusion there. So I'm going to do all of these, the 10 first up here. I just find it slightly awkward getting the bend on these ones right. So there should be the exact right number of parts for everything. So there shouldn't be anything left over. It'd be fairly easy actually for me to include a few extras, and I kind of thought about doing that, but I decided it would just be confusing, basically. If you do find you need extras, drop me a line. If you have problems building the kit, send me an email. More than happy to send out extra resistors or bits if you've screwed something up, or if you've like killed one of the 555s accidentally or something. Let me know. Okay, let's make sure they're all kind of bent such that they'll stay in place, more or less. Again, that works quite well for the diodes, doesn't it? That one's not staying. And again, just doing, I'm going to try and do one pin. Because of this board, there's so many of them next to each other, they kind of move in and out. It's sometimes difficult to know which is the one pin, and I end up soldering in both legs. Let's give it a go. Just hoping I have enough space on my phone to record this whole video. Otherwise it's going to be a two-parter. Okay, looks okay. Good enough. So you've got a couple of resistors still left over because they're for the clock and the Punk console. So make sure you don't lose those. looks good. Let's do the other legs. Okay, so that's all the like the batches of 10 components done. While we're doing resistors, let's just use up the last 2 resistors. So one of them is for the Punk console and goes just here. And the other one is for the clock. It goes over here, just bend it. Bend them in. Enough. See, I should have done those one leg at a time. Okay, there we go. That's it. So I just pushed it through a bit more. Okay, what should we do next? I think I'm going to solder in the semiconductors next. So make sure, you know, there's only one place they can fit, so there's no kind of issues there. But make sure you get the tab. There's a little tab on the chip, like an indentation, and make sure that's aligned with the marking on the board, just to get them the right way around. Let's see if we can. The pins are kind of splayed out on the chips, so you'll have to push them in. But it's nice to have a little bit of spring in them so that they hold themselves in the board and they don't fall out while you're soldering. They're static sensitive, I guess, so you know, officially you should use a wrist strap, although I have never in my life really had a problem. So you might want to, you know, use a wrist strap if you're particularly paranoid. If this was like production orientated, I would definitely use a wrist strap because you can get static damage. But for this stuff, it doesn't really matter. Maybe touch a bit of metal or something. So it's going to fall out. So the 555s, the little ones, don't hold themselves in quite as well. So you might need to just bend the legs a little bit, or just pushing them out a little bit so they keep themselves in. Make sure they're staying in. Oops, don't really want to bend them too much. This looks messy. There we go. And then I'm just going to solder them all in. And again, if you're concerned about alignment, you can just solder one pin in. Like if you're concerned about them being nice and flat, you can just solder one pin in, but I've bent them and they seem to be staying in nicely, so I'm just going to do all the pins. This is not a soldering tutorial. If you want a soldering tutorial, I recommend the EEV blog ones. I think, honestly, those are kind of the best. I know some people don't get along with them, but it's quite complete, and he goes through all of the tools as well, what you need. And then there's a quite nice description of through-hole soldering, and goes on to SMD stuff as well. So all the kits I do are through a hole. But I wonder if there would be any interest in surface mount kits. It's not, surface mount soldering, for those who haven't done it, it's not actually that bad. You need probably a cheap microscope. It's nice to have, but not 100% necessary for the bigger components. So like a $100 microscope is what I used to use. Now I have a fancier thing, which I picked up cheaply at an auction. But you can use these like kids' hobby microscopes, like 20x microscope. It's fine. So that's all the chips. Let's put the remaining variable resistors in. there's just two of them. Again, one for the clock, and one for the punk console. And just bend the legs, get them all nice and flat. And just like before. So this is kind of the home stretch now. It's just a few little components to do. Hopefully it'll all work. So it's interesting, recently a friend showed me some kits that he'd picked up at a car boot sale. Someone had tried to build them already, and they just looked, none of them worked, and it was really sad. I thought, because clearly this is kind of maybe put somebody off soldering for life, because they had these big blobs of solder that had all beaded up around the components, and it looked terrible. So that's why I want to kind of do the videos with this, is just to make sure people know what it should look like, or what a working one looks like. Let's not do the switches next. Let's do the other passive components. So I'm putting in the electrolytics, and they're marked on the board. So there's a white part which goes against the minus on the capacitors, and again there's one for the clock, and then there's another one for the punk console. So yeah, so seeing that those broken boards made me think, well, there are a number of things that went wrong there. One is the guy probably didn't have good tools, didn't have good solder, I would guess, and was using probably a fixed temperature soldering iron, which didn't have much heat capacity in it, and just could not deal with the components. But also probably just didn't know what a good joint looked like and stuff. So I think it's worth making sure you have a semi-decent soldering iron. By semi-decent, I just mean something temperature controlled that costs maybe $40 on eBay now. They're not very expensive. But yeah, try and make sure you have a temperature controlled soldering iron, and good solder actually is equally important. Because I picked up some solder on eBay, on Amazon a while ago, and it was just terrible. So I would go with some kind of brand name solder, and they have lists in the guides for that. This is like a Weller brand solder, I think, this unleaded, and I generally use Goot in Japan. Okay, so next the ceramic disc capacitors. So there are two, and the bigger one is the smaller value, so 0.01 microfarads goes here and is the bigger capacitor, and 0.1 is the smaller, so it's counterintuitive, but I wanted to make sure I got capacitors that were physically different sizes, so it was difficult to get that wrong. You didn't have to go reading the little labels. For the capacitors and stuff, it's tempting to get like cheap components from China, no name brand ones, but the electrolytics are Panasonic brand, and I think the other ones, you know, the other ones are ceramic ones. I think are Vichy. I can't remember. Okay. But I've tried to buy decent components. So the kit should last for reasonably well. The things, you know, there are a few parts I can't buy brand name components for because it would just increase the cost of the kit. And those are the variable resistors and the LEDs and the speaker. Okay, so switches. Where did I put the other switch? There it is. So I don't think it really matters which way you put these in, but I tend to put them all in, like there's holes on the side and I get them all like the holes lined up. And again, these kind of push through and will then push into the PCB, so they'll stay in place quite nicely, but they need a little bit of force to just get them in. And these are the step selection switches. There's no power switch, it's just the way it's designed. So you just unplug it, unplug the battery when you're done. This step selection was again something people really wanted, so I added it. I was a little bit reluctant to add it because again, those increase the cost of the kit. So the things that are expensive actually are not the ICs. The things like anything with mechanical parts is kind of expensive. So switches and variable resistors. And the PCB itself also, so that's why I always try and keep the size of the PCB down to 10 by 10 or 5 by 5, because that's where it breaks down, you know, with the suppliers I'm using. Okay, now we just have to connect the power and the speaker. And the cable for the speaker is kind of pre-cut, and the power one is kind of pre-cut. You can kind of twist them up. So if you just want to keep things neat, you can twist them up. You also can either mount them through the top of the board or from the underneath. And just to avoid the cable going over the top of the board, I'm going to mount them underneath. So you want the red wire to go to the plus on the power connector and the black wire to go to the minus. And just make sure you have those pushed over. Another thing you can do is, because the cables are likely to be the things that go because there's mechanical stress. So if you have, once you've got it all built up and working, you can put some epoxy or like people use silicon, like a silicon compound to seal them in place. Or you know, if you haven't got any of that, you can just use some super glue. I've started using these new speakers, and they're actually marked plus and minus on the speaker. So just, and we can solder like where it says plus and minus. That's where we add our cable. So just add a little bit more solder to the pads, and then what I do is I kind of push the thing in, hold it down, and then keep it heated, and I add a little bit more just to make sure it's nice. That is not nice. Just make sure it's pushed down, and be careful you don't burn yourself, because you are adding quite a lot of heat. So yeah, so always be careful you don't burn yourself. And then the negative ones, just add a little bit of solder. So you want to leave a soldering iron on there for a little bit, just to make sure it gets up to temperature. So yeah, normally I would kind of twist these up a bit, just to make it, because it makes it neater. But I'm not going to do that on video because it takes too long. Okay. And again, plus is on the top here. Just to make sure this is twisted. I twist these before I send them out, but just you might want to check it. So let's do the plus on the speaker and minus on the speaker. And there we go. So let's plug it in. That's it. So that sounds kind of working. There we go. So that is working. So you can see the LEDs going. It's not making a particularly pleasant sound at the moment. There we go. So that's too loud. So this is in 4-step mode. So all down means nothing, and only one switch should be up at a time. So up on the 4 means 4-step, up on the 8 means it will go to 8 steps, and up on the 10 means it will do all 10 steps. If you do something strange like do 8 and 10, you'll start to get weird things happening. So you may want weird things happen, but you can see like it's skipping a step, but you know, that's up to you. So yeah, you can do 4, or 8, or 10, and you can adjust the kind of sound it makes by fiddling with the monostable. And it will create a rougher or nicer sound. And then you can adjust the speed with this pot. So that's it. Let's unplug it. So after building it up, I also include a piece of tape, and you can kind of tape. This is kind of up to you if you use this or not, because it does make it more harder to change the battery. So you'll need to get some more tape when you change the battery. But the way I quite often do things is tape it up like that, and then you can sit it on table. And it's kind of nice because you can see all the LEDs underneath. Obviously push in the rest of the knobs. You could, I guess, glue these in, but they seem to stay in quite well anyway. So there we go. That's the completed build. And yeah, about an hour on the camera, but I think we can probably do it a bit quicker. But there we go. Thoughts and comments, most welcome as always. But yeah, thanks for watching and hopefully purchasing the kit.